If anybody is removed, please try login again. Okay, so I think I'm audible. So I'll show you how to log into Matlab. I think you know it already. So I will show you exactly how to log into Matlab. I think you are viewing my screen. So if somebody is not seeing what's happening, please let me know. Are you able to see my MathWorks window? One of you please say yes or no.
Yes, sir.
My MathWorks window is visible.
Yes, sir.
The audio was off. Kindly just tell me if my MathWorks window was visible to you or not. Yes, sir. Kirti is saying. Thank you. Thank you, Kirti. So my MathWorks window is visible. Now here I have just shared a link to you. So few people who might not have joined MathWorks initially. So I have just posted a link that is https://in.mathworks.com.login. So this kind of window you will get. So you go slow. I will give you some 5 minutes to log into it. Other division students, I don't know how much they do. As well as in A division students also, we have done lab 1 or 2 days, but still there might be problem in how to log in. So I have shared a math work link. If you click on that link, it will give you this window, and then in this email I will put my Gmail ID. So it is smitra@git.edu. Then it will ask for my password. So as soon as I give my password, I will be channelized into this Matlab link. Kirti, just tell me know whether my account is visible to you. Just tell me yes or no. Anybody, please tell me know if my account is visible to you or not.
Yes, sir.
Kiran, because see, I am into my account, so I cannot access Meet and my account together. So just say yes or no. That much will do. I think this my account is visible to all of you, right?
Yes, sir.
Okay, thank you. That will be enough. Okay, a lot of people are still asking for admit, so I have to do that. Fine. So this is my, so the students who are from other divisions or who all are from A division but not done previously. So this is the last time I'm explaining it, and I have already uploaded one video. So that video also I'll share in the common group. This whole process is done there. So that link is there. If you and those who are not having laptop or PC desktop, please arrange one, because in this semester also, or at least coming few days, as long as it is lockdown and all, we will be doing it. This is try login, fine. So we will be doing all the labs by using our laptop only. Because a lot of people are asking for admit, so I have to be here somewhere. Fine. Just give me 1 minute. It is storm. Okay, I'm back. So now, see this exercise we have done previously, but now what I'll do is, hello, hello, hello. Okay. So now what I'll do is how to go into the courses. So more interested in courses also. So here you are finding there are there are 5 actually tabs. So if you press on my courses, so then it will take you to all the course links. Okay. So see that I have started this Matlab. So here this is the Matlab on ramp. Many students have already completed the Matlab on ramp. Now I'll tell you there is another person, Nabil. Nabil, are you here? My voice is breaking. I can't help because I'm with the full network and is anybody else is saying my voice is breaking?
No, sir.
Ehtisham is saying my voice is breaking. Anybody else saying my voice is breaking?
No, sir.
No, sir. Fine. So Ehtisham, just stay on with me. I think and whatever things I'll be doing, I'll be doing by Aishwarya. Thank you. So I'll be doing it on Matlab only. So if we are able to visualize it, it is enough. Okay. Chinmay Kulkarni left the meeting. Fine. So this is what we are finding is so still student joining. So I think it will go up to 5 o'clock only. Okay. So here you are finding that Matlab on-ramp certificate, and students, you can find there are a lot of other courses also. So there is a student called Nabil. Nabil has completed Matlab on-ramp, Simulink on-ramp, and machine learning on-ramp. So this machine learning, deep learning, reinforcement, image processing, signal processing. So the signal processing is what you are going to do in your this semester course. So you are doing DSP, so signal processing, and you are doing so image processing is also a higher version of signal processing. So all these things you can do here. So all these courses, and finally this control design on ramp. So this we will start from 15th of May. Okay. So I'm giving you time till 15th of May, at least for A division students. Again, this will be compulsory control design on ramp with Simulink. So I request to all A division students, because I can make it compulsory for them, and I'm making it compulsory for them. That is Matlab and Simulink. These are the first 2 things you have to complete within another 1 week. Okay, and then directly we will jump to the end control design on ramp with Simulink we will do, and then there is something called as system modeling. So if you are finding here Matlab for financial applications towards end teaching with Matlab, and you will be finding something which is called as modeling with Matlab. So here, this is the modeling and simulation with Matlab. So modeling, whatever mechanical system design you are doing at present, that is actually mathematical modeling. So we can predict when the COVID is going to end, or how much people are going to die, or what is going to be the financial state of country during COVID or after COVID. So all those things we can do by using system modeling. So this is our last target. So if we can do this modeling and simulation in this same, it will be good. Okay. Matlab on-ramp and Simulink on-ramp division A students, you try to finish as soon as possible. And Simulink does not require, again, it is not needed to be it is not needed to be downloaded, so nothing is needed to be downloaded. It is a software as a service, or whatever thing we are doing, it's a service, it's a cloud-based thing. So students, please get it done. Matlab on-ramp, Simulink on-ramp, and by 15th, we'll start with this on-ramp. Now this is the course page. Now we will go to the previous thing, that is previous page again by backspace, we can go to the previous page. I have come to here, and now I will start with MATLAB Online. Okay, so such a window will come, and we have already done experiment number 2 quite a lot, but I will explain few of the things in experiment number 2 again in 10-15 minutes. So for everybody, this is a session for everybody, and we will try to cover as much as possible in this experiment. So if anybody is having any problem in hearing or any other doubts, please ask me. You just ask me, sir, I have doubt, and you ask likewise. Okay, so I have launched. This is how the MATLAB window is going to look like, and still we are having the code that was done previously. So I was doing the code as all waves. Okay, so this was the name of the code. If you want, I will show you exactly how to take the code. So first thing, I'm having a MATLAB code with me. So the MS Word document that was given to you, I think you can see it in the screen in the left side. So I will start my just so I will make it little smaller, the window. Okay. So now what is there? I'll go to the MATLAB and I will access a M file. So before that, I will just copy a part of the program. The program we want to see. This program is, you can see this thing in the MS Word window, and I will copy it. I'll copy it like this. Only the first part I have copied, and like this I have copied. And then I have to open a new script. So I think this window is visible. Kiran, just let me know, just say yes sir. My command window is visible
Yes,
to
sir.
you, right?
Yes, sir.
Fine. So now I will take a new script. So this is how M file is created. We have done it previously. So students, just bear with me, because this session is for everybody. So I think they also have done it in their class. So just click on this new. Okay, so click on this new. It is going to open a file like this, and whatever thing I had copied, so I paste it here, and then I will save. So you can save it like don't give name as code, add, subtraction. Just don't give name. I will give name as Saurav underscore 1st May, like this. I can give that name. Okay. Then okay, if I do, you can see here, this is the place where the name will appear. So the name should not start with a digit. It should not start with 1 Saurav. It will not take. Okay, so this is my code. So on 1st May I'm doing it. So this is Saurav 1st May, and this is getting stored in the space which is allocated for you in MATLAB. Okay, so WhatsApp, some messages there. Just let me check. Yes, sir. Vaishnavi has logged in. Fine. Fine. So this is how it will look like. So Saurav underscore 1st May dot M, and it is got stored. Okay. So now we can start executing. See, previously we had done this all waves. Okay. A lot of codes were done. So I was just copying the code from this thing. So this is given to you already. So this MATLAB code is given to you. So you just keep on doing it with me. And if you are not able to execute it, or some problem is there, please raise your voice and then ask me, because I am not able to see my window. So this window I will not be able to see. So whenever you are having some doubt, I will be a Matline. So whenever you have any doubt, please, yes sir, tell me what it is. Okay, so I am switching my window on, Siddharth Angadi, like this. Fine. So what we are going to do is, first, this is going to be a code for generating many waveforms. What we have done, so CLC clear all, close all. I think you all know it. CLC clears the command window, clear all. So this is the workspace. A lot of variables and all these things will be stored here. So this variables will be cleared by clear all, and close all. So if there are some window opened, okay, in related to MATLAB, like there can be some window of image, there can be some other window related to data and all those things. So everything will be closed. This is the first thing. Second, you have to define a time. So we are defining a non-causal time. So from -10 to 0 and 0 to +10. And here there is a transpose kind of a thing. Somebody else, there is some sound. Okay. So what is the significance of time? I am defining a non-causal time. Okay, so you can define it from 0 to 10 up to 0.0 and also likewise. Now I will just make it short little bit because I will do it from -5 to +5 because 10 is very big scale. Now I am first producing impulse response. So impulse is equal to t equal to 0. Subplot. So subplot is a command where here 331. So subplot means many plots I am representing in a matrix form. So 3 means 3 row 3 column. So I am going to plot 9 waveforms. Okay, in that case the first position. So it is like this: for 1 2 3 4 5 6 7 8 9 row wise. So these are the 9, and if I want to plot 9 waveforms from the beginning, I know I want to plot 9 waveforms. So I have just made my situation. So third row, third column, 3 row, 3 column, and position 1. Okay, so at position 1, this impulse is going to be plotted. And then plot t impulse. So whenever you are, so this is a function you have defined, and t impulse you are keeping in the square bracket, and whenever you are keeping impulse in the square bracket means this is a variable that you are doing. Okay, and then red is going to be the color of the graph. So there's going to be impulse waveform with a red color, and I'm actually explaining everything. Then x level, so this is whenever you are writing what is the axis, name of the axis. So x level means there's a function, x level is time, y level is impulse amplitude, and title of the graph is impulse waveform. So this axis I will show a percentage command before that. So percentage means it is showing in green, means it is not executed. So let us first execute it. So first save it. So I have made some changes, small changes in the code. So A division students, please bear with me another 10-15 minutes because it's done. But again, we are redoing it for us because I have to take everybody together. So changes I have made this -10 to 10. I have made it from -5 to 5. Then here is a transpose, and then I have shown it by subplot. So I will show you, if you are not doing it by subplot, then what. So first I am commenting this subplot also. Okay, so again save. I have commented, either you put percentage sign or you select something. So there are two ways: you select this like this and right click and say comment. Okay, so it will be coming comment, so it will not be executed. So now save it and run it. So run is a green key on the top. On file version there is a run key, and run it. So as soon as you're running it, it will show you what is the impulse waveform looks like. So it will take some time because depending on the speed of internet, because we are directly accessing all this thing from the cloud. So, and it is already very cloudy. So already cloudy means internet will be little slow. Okay, so it is taking quite a lot of time. Okay, so now this red thing is visible. The red thing is visible, but see that baseline is also red and amplitude is occurring at t is equal to 0. So this is what it is, and you can just squeeze it. So this is what it looks like. So this is what is a impulse response. So x level, it is shown here. I think x level it is shown as time. So this is, so here it is called as time. Here it is called as impulse amplitude. Here it is. Okay, so my Matlab has got reset. So again it will come very fast. Don't worry. Okay, so this is what the comment. So a lot of functions we are using, and try to use as much function as you can. Okay, so in the command window, if you want to know about some function, suppose access is a function and addition is a function. So you just write add, and you can ask that function. Okay, so now it has returned. The whole code has returned, and I will run it again, and let's see how it goes. So sort of first May is being executed. So command window it had shown, and the figure will come like this. Okay. Now two things I will do. Everybody got it? If any problem is there, you please ask. If anybody is having any problem, please ask me. Yes, sir, this is the problem I'm having. It is not getting executed. That's a problem at your side. Internet issue, no problem. You can execute it at your side. So please sit with pen and paper. So even if you are not able to execute it, at least write down which function does what kind of thing. Okay, now I will do one thing. Now I will use this axis command. So what is axis? Axis actually gives me area. So first one is x min. So it will be actually I'm putting a kind of a zooming. So that zooming thing I can do by axis. So I can define the axis which I want to be displayed. So what I'm doing is I am defining from -1 to +1, and I want to see from the below. So this is x min first, this is x max, y min, y max. So if I'm doing that, y min I'm defining as -0.02. Now in this graph, y min is 0. It is automatically taken. Y max is 1. So hence amplitudes I am not able to see very clearly, but I want to see the amplitudes very clearly. So what you do is you take the y-axis little bit below than 0. So that's what I have taken as -0.2. You take the y-axis max little bit above than what is appearing to be the max amplitude 1. So 1 से थोड़ा ऊपर ले लो and 0 से थोड़ा नीचे ले लो. That's what I have taken, -0.2 and 1.2. And I am going to show you -1 to. So if you are executing it, just check what it will come. So I'm bringing the axis command into the function now. So now just see what is happening. So this is what it looks like. So still people are joining. This thing will go on, I think, till 5 o'clock. Okay, so this is now what is happening. So I've defined the axis. Now see that here it is -1 and here it is +1. Okay, and here it is 0. So at 0, impulse means at 0 the amplitude will be 1. Okay, like this. So from -0.2 to +1.2. So now I can very clearly see what is the impulse response like this. Anybody asking anything? No. Okay, so this is how it is. Now you want to see what is there. What you do now is we will go very close to this center 0 point. So what I'll do is I will display from 0.1 and up to 0.1. Okay, so this I will do. So I'm displaying very close. So I'm going very close to this and I'm finding what exactly is happening. Okay, so -0.1 to +0.1. So I'm going very, so I'm zooming it. Okay. Then what you get. So again run it. So I have changed the x-axis, y-axis I have kept same, and you will see them. So real fun of Matlab is when you are doing it on your own. Akela बैठ के you are just checking everything and you are just playing with some of the functions and scales and you are getting the output. Then this is the real fun. See, this is how the impulse function looks like, because I am plotting it from -0.1 to +0.1. Okay, so now here digitization. So the impulse actually looks like a kind of a triangular wave. Okay, this is if you are going very close. So this is a microscopic view of the whole thing. Now if you just remove this axis command, now save and run, and now you're going to pull the previous thing. So today internet is running a little slow, almost half an hour down. Let's see how much we can do. Okay, so this is the initial impulse command we are going to get. Now somebody wants to say that, sir, I want a shifted impulse. So the same thing will be applied for other things also. I want to shift it in a time domain. So how can we get that? So this is from -5 to 5 I will display in axis, and I will show you a shifted waveform. So now impulse is equal to t is equal to 0. So I want the impulse to be at suppose 3. Okay, I want the impulse to be at 3. That means I want a 3-unit delayed version. Then I have substituted here impulse is equal to t is equal to 3. So let's see what it happens, what it gives. So this is called actually time delay. So I'm delaying the waveform by 3 units and displaying the same. So here time axis is from -5 to +5. And here 0.01 is a sampling. So smaller you are taking this in intermediate value, better will be your representation. You can take 8.01, again execution time will increase. So I have taken at 0.01, that's why it is taking quite a lot of execution time. That's from -5 to +5. This 10 seconds, and that divided by 0.01. That means it is actually calculating from -5 to 5. There should be only 10 instances, but actually it is calculating 10 divided by 100. That means 1000 instances it is calculating. So if I make it -5.1 up to 5, then it will be calculating 100 instances like this. So I have run it by wasting quite a lot of time. And what I'm going to show is actually it is a delayed impulse. So impulse is delayed by 3 units. So previously it was t equal to 0. That's what getting the impulse starting at t is equal to 0. But now I have done it t is equal to 3. So it will be shifted right by 3 units. Suppose somebody wants to do t equal to -2. That means the impulse will be shifted left by 2 units. So it is taking quite a lot of time. Again, I will run. So let's see whether it comes on. So it's all about internet issues that are coming. So today it's cloudy, so internet issues will be more. See, okay. And how do you know whether it's 3 or not? So you take the cursor here. So 0 is here. This is 5. So take the cursor here, and the cursor will show you the amplitude. Okay, so here it is not showing. This is 3.03. That means the impulse is shifted in the right by 3 units. So what I'm doing is here t is equal to 3. Now if I do it -2, so first cross it. So this t is equal to 3. It was there. Now I'm doing the same thing at -2, and the same thing you have to do for every waveform, whichever I show. Okay, how to parameter is to be shifted, and you have to shift. So time shifting, time scaling, and all those things you should know. So see that now it has come to, so this is 0, and left side it is -5. Now it has come to -2. How do I know it is -2? Let's see, if you just bring the cursor here, there is a very small gray thing. It is coming almost at -1.98. And this is at -2. You can stretch also. You can select this axis like this. So you can select this axis as -2.1 up to +2.1 up to -1.9, okay, like this. So you can do that. You can select -2.1 to -1.9, and amplitude is same. So you do this. So this is kind of a zooming that you are doing. So just see this waveform, it will be now zoomed. So by axis command, actually I am zooming it. So I know I am displaying it at -2. I have shifted this t at -2. So you want to check only that it is displaying 2.1 to -1.9. Okay, so -2 is exactly the same, and this is looking like a impulse. Fine. So all the things are explained. So I'll again go back to 0. And I will remove this. Last thing I will show you is from this graph what is meant by subplot. Okay, so subplot you execute. So this will be the first waveform. This will be the first waveform of 331. 331 means 3 row 3 columns. So the whole figure area will be divided into 9 parts, and the first part is this waveform. So what is the mistake I have made? Mistake is I am showing the t at 0. So impulse is at 0, but I have kept the axis at some other value. So remove this axis command, and like this, again you will be able to see what is the impulse at t is equal to 0. So this small errors happen. So if you make error, then only you are going to learn. So you have to play with it. That is the first thing. So I never had a formal introduction of Matlab. So this whole area, this is the whole area of the waveforms. So this is the position 1, 1. This is position second. So this position, if you want to display, what will be the 2? If you're looking at 333, likewise. So just show it at 336 where it is. So this is 331, 332, 333. Then 334, 335, 336, and 337, 338. So likewise, 9 waveforms we are going to show together. So I'm not displaying it at 336. I'm making it 336. So it will be displayed in the 3rd column and 2nd row. Okay. So just see whether it happens or not. Same thing you can do. You can give some other name also. You can display it at 337. Doesn't matter. So it is taking time. So what I'll do is I'll remove this, and it is at 336. I will save and I will run. So today internet is little slow, very slow. Okay, so it's not happening, but that is how the subplot command is to be executed. That is just got stuck somewhere like this. Fine. So these are the things that I had to tell you for the first set of experiments. Let us have the whole set of experiments. So in the second code, so this code we had executed in full. Second code, what we are doing is we are actually finding what is step response. So take that code. So a lot of changes you can do that. So you can save it. You can save it here. It has become okay. So minus 2.1 minus 1.9 all this. So this is x main, x max, y max. So the to sit more closely. Like that. So that's what we are producing step unit step. So this is greater than equal to 0. This is unit step. Starting t greater than equal to up to t is equal to infinity, amplitude will be unit step. So unit step means amplitude will be 1. If somebody wants 2 of unit steps, this case to display 2 unit steps likewise. So this is called as amplitude scaling. Okay, so substitute for t 2 star unit step. That means whatever is the amplitude of unit step, that will be multiplied by 2. And this is the color of the graph. This is blue. So previous case the color was red. Now in this case it is blue. If you want this color to be also red, you can remove this red and you can show that as, you can remove this blue and you can show as red. So how many waveforms we are going to get here? We are going to get 2 waveforms, and every waveform should be given some kind of access command here. Okay, so here also I have access, and we are going to get 2 into unit step, and that is going to be displayed by red color. Likewise, so I have pressed the run button, but run is not getting executed. Let me see, let me wait some time and find out. So no message in your group, and that means people are going strong. So meet, there is any comment so far? No comment. Okay. So Matlab online, I think it has got stuck. So what I'll do is I'll refresh it. Or what I can do is I can go back. No problem, persist. Please contact the technical support. So such kind of refresh is required at certain times. So Matlab online, I'll go. And it will start exactly the same point where I left it. There may be an internet issue somewhere. It is getting stuck. So you have to go very slow. So you people have, many of you have done this Matlab online certification, Simulink online certification also you start doing, and many times you will get, due to internet issue, you will get stuck. So start afresh, log out, and then clear your all cache and other thing, all the cache memory and everything, temporary files and everything, and then again you start. Okay, so those things matter like this. So it is taking time to load. So now it is loaded, and just check that it has loaded from the same thing. So this solve school first May. Okay, if I log off and again log in, you will find that here it will be showing. Okay, so these are all the cases, that these are all the codes that we have executed. Likewise, so this sort of first May, just check here. Okay, so the sort of first May is stored here. So this I can remove, delete. I can do that. Delete this file, and this also, if I want, I can delete. Okay, so likewise you can delete and you can again start. Okay, so now I'm here. I have put this subplot impulse command, so the step command is not taken. So again I'll copy the step command like this. So copy, and I'll paste it here below to this. So unit step t greater than 0. So this is plotted at 332. So then I'll save it and I'll run it. So below in command window they had just shown underscore first may.m. Now the figure will come. So impulse will come first and in position of 331, and then step will come at position 332. Just see that. Okay. And why it has come like this? Why it has come like this? Because you are showing it from the axis and minus 0.3 and 1.3. So minus 0.3 means little bit below. So lowest of unit step is 0. So usse thoda niche, and 1 is the highest point, usse thoda upar. So this give you a clarity of how the waveform looks like. So if you remove this axis command, so two things I'll do. First thing, I'll remove this axis command, how it looks, and I'll change the position. Maybe I will display it at 338. Okay, so this is the subplot hand, and I want to display this unit step by another color. Okay, so that color can be green. Okay, so three changes I have made. Whatever is the waveform here, I have made three changes. First changes, I will display this by a green color. Then I will display it at position 338. So if it's 331, 332, 333, position 4, 5, 6, 7, 8. So it will come below somewhere here. And I'm displaying 2 of unit step. That is another change I'll do. So 2 into unit step. So this amplitude is now from 0 to 1, but I want to do amplitude scaling. Okay. So I will display it by 2. So that is there. And what another change is there? So this is the thing, this unit step. So axis I have removed. Axis I have removed. That is the first change. 2 into unit step. That is the second change. Red has converted to green. This is the third change. And subplot is at 338. So I'll be changing position, and I'm not playing with the impulse response. So first you have to remove this, and then you can run, or together you can do. So it was better if I had removed it first, figure, and then run it. So just say 4 changes has come. So from position 332 it has come to position 338, and I have removed the axis. So it is from -5 to +5. But you can see here the problem is the -0 and +1. It has merged with the borderline. Okay, so that is a problem that has come. And amplitude is 2. So you can find out the amplitude is 2. It is very uncleanly way shown here. So this is 0, this is 1, this is 2. So what you can do is you can bring the axis command into picture. So you can do it from 5, -5 to +5, and -0.3 to 1.3. So remove it and save it and run it. So actually 3-4 different commands I'm teaching you. What is subplot command, what is axis command, what is plot, how to play with her, how to change the amplitude, all those things I'm showing you together. Okay, so here the problem has occurred that this amplitude is 1.3. Amplitude I have kept at 1.3. Why amplitude? That's why it has got cut. So make it 2.3. So mistakes happen. You should not get scared of mistake. Mistake will happen, and if you are making mistake, then only you are going to learn more. So what changes I have made now? Previously it was -5.3 to 1.3. So that's why our header of the unit step, it got cut. So now head we will show properly, and in the graph it will come, and just wait. Okay, so now everything is very clear. So now it has become green. The graph has become green. You can check the position 338. So 3 means 3 row 3 column, and this is height is 2, and all those things are there. Now somebody says that I don't want 9 waveforms. I want only 4 waveforms. So how can you change that? So impulse you can make 2 to 1, and this plot you can make 2 to 4 likewise. Okay. So instead of 3 3, I am doing now 2 2. 2 2 means I am dividing the whole area into 4 parts. And the first impulse I am showing it as 2 to 1, and as 2 to 4 likewise. So this is save. I'm sorry. This figure you have to remove. So this is save, and this is run. So same thing, whatever was done last day for division, actually I'm repeating. So I'll go for the next code very fast. So I think I'm sure that other division people also they have executed all these codes initially, but I just wanted to build a environment for execution. That's what I'm doing it. Again, Matlab has got stuck, so it is not happening. So what changes I've made is I've changed this thing 2 to 1, and this is 2 into unit step. That means whatever was the unit step, I'm making it double, and this axis is there. Okay, so the axis is there, and instead of 2 to 1, I'm making it 2 to 4. Okay, so this is 2 to 1, and this is 2 to 4. So I'm dividing the whole area of the display into 4 parts. So it's a matrix of 2 by 2. So there are 4 positions: 2 to 1, 2 to 2, 2 to 3, and 2 to 4. So just give me a try. Let me give a try and just see if it can happen. So there is coming an internet issue. Now let me execute the whole code together. There were 9 waveforms. All those things I can display together. So it is getting stuck. So let me refresh. Again, Matlab online. So Tuesday morning we are doing the lab for division A actually. So that time, morning time, internet is very good. So it is easier for us to execute all the codes in the morning time very easily. Okay, just see that the same code has come. So exactly wherever you are leaving it, the same thing will come. So here it is not getting registered. You can see that the changes are not registered. So this is 2 to 1 I'm doing, and this is 2 to 4 I will do. And like this I will do. So it is not getting registered. That means I'm not having a good connectivity with the Matlab cloud. So we are accessing this codes directly from the cloud, and there's a not very cloud means internet. It is connected through internet. So whatever code I am doing, it is getting executed in the cloud. So now see what has happened. So first thing I have done is subplot 2 to 1. So 2 to 1 means this is the position 2 to 1, and this is the position 2 to 4. Okay, so here the axis is -5. So -5 to +5. You have seen this is a green, and I have made it 2 into unit step like this, and here the position is 2 to 4. Now somebody says I want to shift this waveform unit step in the right side by 2 units. Okay, so I want to shift this unit step waveform right side by 2 units. So what you make is t greater than equal to 2. So previously t was greater than equal to 0. Now what I'm making is I'm making t greater than equal to 2, keeping everything else constant. I will just shift this waveform to the right side, and green is not looking good, so make it blue. Okay, so make it blue. Waveform of unit step, make it blue, and shift it to the right side by 2 unit time. Let's see whether it gets executed or not. So every step it is getting stuck. So that is a problem. So now I made this change. So t greater than 2. Previously it was greater than equal to 0, but now it is greater than equal to 2. Okay. It's not getting executed, and I will go back, and again I will come back. So these things are there. I will remove it. Other things, WhatsApp and all. So Matlab online. Let me refresh my window. So all the codes are given. What I ask students is you just try everything. So A division students, you have to submit this experiment exactly the way I have done it. You do it that way, same that way, and so this is now 2 to 1. Okay. See, this is 2 to 4, and this green has to be made as blue, and here t greater than equal to 0, so I'll make it t greater than equal to 2. Likewise. So now save it and run. Now it will happen. Now you'll find you shifted or delayed by 2 units. That is what you're going to get. So this delay also we can reduce. We can reduce the delay by making this time. It is from -5 to 5 with steps of 0.01. So now I'll reduce it because it is taking quite time. So I'm taking 0.1. So step of 0.1. So every 1 unit of time is now divided into 10 parts because sampling instant I'm taking as 0.1. So this will make the execution a little faster. So previously I had kept between -5 to 5 and I was taking the sampling time as 0.01. So it was actually calculating -5 to 5 means 10 units divided by 0.01. That means it was calculating 1000 points. And 1000 points was displaying the two graphs. So two graphs displaying 2000 points. So now as I have made it from -5 to 5 as 0.1, so suddenly I have reduced the load by 10 times. Okay, so now -5 to 5, that 10 unit of time is getting divided by 10 times. So now there are 100 points. So if I'm displaying two graphs, then there are 200 points. So let us stop this and let us start executing this. So -5 to 5, it is now 0.1. So I think it should be more easily executed. Let me see whether it gets executed easily or not. Uh, so actually we are reducing the load on the execution. So online execution, we are reducing the load. Now see, okay, so the load is reduced. You can find out because very fast it has happened. So this is how you think of optimizing the system performance. So when system is giving you very good performance, no problem. But if it is not, then you have to reduce the load. So first thing you can check is this is the impulse. There is no change in it. And second thing you can find it that the step has shifted by 2 units. How do you know it is 2 units? Just check where is the x showing. So x is showing around 1.9. So perfectly placing, you will be finding it is right side and it has become blue. So now your unit step has become blue. Likewise. Okay. So remove this figures before we are going to execute all the 9 graphs. This graph, whatever was there previously with 0.01, it is still executing. That you have to understand. So that's why this is showing this thing. Okay. So now bigger graph it is there. So figure 1, you can cross it and it will come here like this. So these are the changes you can see like this. Fine. So this graph is still, this figure is still troubling us because it is still in the execution mode. Don't worry. So now what we'll do is we'll take all the waveforms and all the 9 waveforms we will see, and I doubt it will execute, but then also just let us give a try. So the full code. So these are the first 2 pages. We are actually displaying all the 9 waveforms. If I don't get to execute all the waveforms here, at least it is copied in my MS Word document. I can show it to you. So what we are doing is the same thing, just I'll tell you. So between -10 to plus, so this I will change first, -5 to 0.12 plus 5. This is the first thing I'm doing, changing. Now I'm going to show all the 9 plots to you. So the first part is impulse. So impulse t is equal to 0. This is the first. So I could not explain to you, A division students, clearly all the waveforms. So unit step, I think I had explained, and you can change t greater than equal to 0. So this you can change. Now these 2 are the basic waveforms. Now whenever you are designing a ramp, so this is TUT. So TUT means T is the waveform, and whenever you are multiplying it with UT, means actually you are generating what is the causal signal. So causal signal is generally in the right side. So this is actually TUT in the right side. And then this is a parabolic input. So this is T square UT we are producing. So this will be a square waveform. Then subplot. So subplot means I'm showing all the waveforms together in one graph. Okay, it is like this: impulse, unit step, ramp, parabolic, and then I'm showing here. This I had changed last day also. This should be decreasing. So decreasing exponential should be negative coefficient, and next one should be increasing like this. So this is e raised to minus 1.2t ut. So this is dot star. Dot star means this is point by point multiplication, and this is dot star. So this is increasing, this is decreasing. Please make this change in your whatever document I have sent. Then exponential is there. Then there is square wave. Okay, 7.5. This is the amplitude square wave. So positive half cycle, negative half cycle, they're same. F is equal to 3. F is equal to 3 means I'm going to show you 3 cycles between 0 to pi. So here 2 pi ft. So let me just find out all this graphs, and then I will explain. So I have executed it with a smaller sampling time. So minus 5 to 5 with 0.1. Okay, so this is my time frame. See, all 9 things I am displaying like this. Okay, so this is the graph you are supposed to get. So everything is done at my side, and I have given you what is the output. So everything is there, and you can find out. Somebody is trying to join in. Right. So impulse I had explained, unit step I had explained, so there is no problem. Then ramp. What is the ramp? So this is the position 333. So this is the position 333. What you are finding is T star dot unit step. That means this is TUT. Because the TUT means it is starting at T is equal to 0, and at 5 the amplitude is 5. Okay, so here you are finding the amplitude is 5 in corner, very short, you can find the amplitude is 5. Okay, so likewise. And then I am finding a parabolic waveform. Parabolic waveform, why is it showing difficult? Because the axis here is between 10 to 10. So if you are making the axis between 5 to 5, then you will be able to see it better. So this is from minus 5 and up to plus 5. And t square. So t square is 25. So we will display up to 30. So what is the t square graph? So x-axis is t. So between minus 5 to 5 means actually you are going from plus 0. So this is parabolic t square into unit step. So unit step is starting from t is equal to 0. So you will be finding that this waveform. So let me just plot it first. Too much of assumptions I'm doing. Let me just plot it, and I'll tell you exactly what is t square waveform. So t square ut. T square ut means whenever you're multiplying this by ut, that means it will start from t is equal to 0. Just see this green waveform, it is starting from t is equal to 0. Because unit step is starting from t is equal to 0. So if you don't multiply this with unit step, then it will be giving you what kind of thing? Just check. Okay, so it is starting from unit step. So up to t is equal to 0 in the negative side, the amplitude is 0. Then at t is equal to 0 up to 5, because time scale I have taken here as 5, not 10. Okay, so this is a fourth graph, 334. So 334 like this, and minus 5 to 5 with amplitude 30. Why 30? Because at t is equal to 5, the amplitude will be 25. So you can find here at t is equal to 5, this amplitude will be around 25. It will show. Okay, so they should show that amplitude is 25. Just say y is equal to 24.01. So at 4.9, amplitude is 24.01. At x is equal to 5, the amplitude will be 25. So I have taken the time as kind of a 30. So that's why it is showing like this. Okay, now what you do is you go for the next waveforms. Decreasing and increasing exponential. So you are finding the blue graph. So you are finding increasing exponential with red. R stands for red, and decreasing exponential will be having a characteristic of blue. So this is plot t increasing exponential with red, and you are finding that decreasing exponential is with blue. B stands for blue. So you can find here the decreasing exponential is with blue and increasing exponential is with red. So I had made a mistake. So whatever file I have transferred you, the top one should be decreasing with e raised to minus. Wherever it is there, it is decreasing exponential, and t raised to plus. So exponential means e raised to something. Wherever it is e raised to plus something, it should be that is increasing exponential. So please check that. Okay, now just do one thing. So with square only we can do. Okay, last other things. So square waveform and other thing I'll explain. But here there is come some problem. Okay, what is the problem? It is coming because of aliasing. So here you are finding that this is a sinusoidal waveform 338. 338 is a sinusoidal waveform, but this is not sinusoidal. Why it is like that? It is, this all are happening because the sampling time I have kept as 0.1. Okay, as soon as I am taking sampling time as 0.01, all these waveforms will be reproduced very perfectly. So this is a very important thing for you. That is sampling instant. That is whatever is coming in the middle between -5 to +5. You have to take all the sampling instant as less as possible. So in the initial code, whatever I have sent to you, the initial time was 0.01. If I'm making it 0.01, you'll be finding everything fine. But in that case, I'm actually asking the cloud to do 10 times calculation. So let's see whether it gets displayed or not. This is a challenge. So if it gets displayed, you will be finding that with this smaller amount of sampling time, perfectly the sinusoidal waveform. Just see. Okay. So this is what I have done. So -5 +5, and what I've done is all this sinusoidal waveform, all this square waveform. So this last three. Okay, this is 337. This is square waveform. This is 338, and this is 339. So let us mainly concentrate on 337 and 338. So let us see the bigger waveform. Whether you get it or not. See here. So this is how it looks like. So between this 0 to 0.5 to 1. Okay, why 0 to 0.5 to 1? Because the axis is checked. So this is the 3. So these are the small things which we should understand. This is 3, 3, 4, 5, 6, 7. So let us go to 3, 3, 7. So this is 337. This is 337. This is plotting square wave. And what is the axis they have taken? In case of 337, the axis is taken from 0 to 1. Okay. So though we are plotting from -5 to +5, but the axis we are taking as 0 to 1. So here you can see that 337, the axis is taken from 0 to 1. So in between 0 to 1, that means 1 second. Okay, 1 second. What is the frequency here? F is equal to 3. Okay, so what is meant by F is equal to 3? In 1 second, how many cycles we can get? That is actually is the frequency. And how to define square waveform? 7.5 square. Square is a function. We are using a function here. Okay, 2 into pi into ft. So 2 pi ft is the frequency. F is defined as 3. You want between 0 to 1, you want 2 such waves. So here now I am getting 3 such waves because I am defined F as 3. Okay, hence I am getting 3 waveforms between 0 to 1. Okay, you can plot it between 0 to 5. You can plot it between 0 to 5. So instead of 1, so x-axis will be 15 cycles, or you can 5 will be more, so you can take 3. Okay, so between 0 to 3. So if 1 second is producing you 3 cycles, then 3 seconds will produce 9 cycles likewise. So let's see whether we get nothing else we are changing, no other waveforms we are changing, only we are changing the display of rectangular or square waveform. We are not changing the any other waveform, but just we are changing the display. Just check here. Just check here. So this is between 0 to 3 you are plotting. So 1, you can check the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 pulses you are getting between 0 to 3. Somebody wants to say that I want to see 0 to 1 and f is equal to 2. Okay, f is equal to 2. So between 0 to 1 I'll plot, and I want to see 2 cycles, and I will change the amplitude as well. So amplitude scaling I'm doing amplitude as 2. So in this case the amplitude was 7.5. So see that between 0 to 5 this was 7.5. What is the y-axis comes? Just check. It will be displayed now. So axis is 7.5 here. Okay, this is 7.5 because previous case it was 7.5. Now I am making the 3 changes. I am saying frequency 2. That means between 0 to 1 there will be 2 cycles. That is the first thing. And next is I am checking the amplitude as 2. Okay. Likewise, so if I am plotting it, Just see what happens. But main important thing is here sampling time I have reduced by 10 times. But now cloud is supporting us, so the internet is supporting us. So just see what all has happened. So here the amplitude is now 2. Okay, it will show you the amplitude as 2. I'll show you the amplitude as 2, and just see amplitude at x, amplitude is 2. So y is equal to 2. That is the first thing you can check. And why is it going up to 5 in y-axis? Why is it going up to 5? Because in this case, square waveform here up to -8 to 8 we are displaying. So if you are displaying from -2.5 to +2.5, in that case you'll be getting a better waveform like this, +2.5. Likewise, if you are doing that, then you'll be getting a better waveform like this. Okay, so 2 cycles you are getting, and you can control both amplitude and frequency. And biggest thing is square waveform is looking like a square waveform because we have taken the sampling time as 0.01. So you go to the top and you just check what is the sampling instant, and you will be finding that sampling instant is taken as 0.01. Okay, here. So -5 to 5, the sampling instant is 0.01. This is the main thing. And you are making it 0.1, and this square waveform will not look like a square waveform. Sinusoidal will not look like a sinusoidal, because in that case that error is called as a aliasing error. Okay, so now the changes made is this is 337, so it is 2 of square wave, f is equal to 2. I have changed the axis, so axis command you should know how to execute it. So it is still executing. Let me just cross it. Again, internet has got stuck. Okay, so I'll go back, I'll refresh it again, and I'll come back. Stay on, because now we are going to, so this we have executed previously. Is there any student from B division? Is there any student from B division? You can confirm whether all these things were done in the class or not. Anybody? Okay, any other student from C or D division? Hello? 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 Hello. Okay, as now many students are gone, so I think only the division 1 students are there. Hello. So I think only the division 1 students are there. Am I audible? Anybody can confirm?
Yes, sir.
Yes, sir.
Okay, so only division 1 students are there. So I think no other division students are there. So this is the first 9 programs I think I had explained to you. So what you can check is what is the effect of sampling. So just keep on making this intermediate value as less as possible. You will be finding that you are getting very good sinusoidal waveform generation. Okay, so that was the first code that we had to execute. So first 9 points, and next we are going to go for the other codes. So this is the output of the first code given. So all these waveforms, you whatever I have shown, other than that something you have to show. So for every waveform, you have to display. So this is the experiment task I am defining. For every waveform, you have to define some shifting or something other than what I have shown. So you can change the amplitude, you can change the color, you can change the time, you can shift it. All the waveforms you have to do. Okay, now this is one thing. What we are going to do is baseband sine wave, its second, third, fourth harmonic displayed together for clearer distinguishment of legend command. Okay, so this is page number 4 out of 19. So this is a code that we are going to execute, and let us see. So everything you can understand on your own, but I'm not teaching you Matlab at present. I'm actually teaching you electronics. So in electronics, I'm going to teach you what is meant by harmonics. Okay, so just take this code and save it as some point. So you can give as harmonics. Okay, so I'm giving it name as S harmonic. So S stands for Saurabh, and harmonics also I have made a mistake in the spelling name intentionally, because harmonics might be a function, who knows, like this. So if you're doing it, you are finding S harmonics, and what is the thing I have done? So I have defined T from 0 up to 2 pi. Why 2 pi? Because sinusoidal waveform is between 0 to 2 pi. So 0 to pi means 80 degree, 180 degree, sorry, is half cycle, and 0 to 2 pi is full cycle. Now I have defined, let me ask, are you with me with the second waveform, sinusoidal waveform? Okay, Shweta Pujari, she has joined. Are you with me in the second waveform, second code? So I'll be explaining. So sine 1. So I am actually doing displaying sine 1, sine 2, sine 3, and sine 4. So even if you are not executing it, just see what I'm showing you, because all the document is given to you, waveform is given to you, so you can find on your own. What I'm plotting is sine t, sine 2t, sine 3t, and sine 4t. These are the 4 things, and sine t is plotted with red, sine 2t is plotted with cyan, there's a color, sine 3t is with green, and sine 4t with black. Now how can I represent all these 4 graphs? So sine 1, sine 2, sine 3, sine 4, all these 4 are variables defined by myself. Now I am using a legend command. So x-axis is time, y-axis is sinusoidal amplitudes. So all the 4 different sinusoidal amplitudes I am showing here, and title is baseband and 3 harmonics. So what is the baseband signal? Sine 1. This is the baseband signal of sine t. Sine t means only one cycle. Okay, sine omega t, so omega is equal to 1 here. Here omega is equal to 2. Next, green is omega is equal to 3, and fourth is black. So instead of cyan, okay, let the cyan be there. And what I'm displaying is 0 to 2 pi in between minus 1.3 to plus 1.3. See, all the sinusoidal waveforms are having amplitude 1. So sine 1 is sine t, sine 2 is also sine 2t, sine 3 is 1. So here amplitude scaling we are not doing. So whenever you are displaying this in your code, whenever you are submitting, so you have to submit all these waveforms with some kind of change. Okay, some change you do. So where you have to make the change, you know. So you can change, you can display the, you can change the time, you can change the amplitudes, but some changes you have to make in the codes, and you have to get the output and you have to show me. So this is a waveform. S harmonics name I have given. I will save it and I will run it. So four waveforms, baseband signal is given by red, then second harmonics is given by cyan, third harmonics is given by green, and fourth harmonic is given by black. And all these waveforms I can display by one command. Okay, so many waveforms, if you want to display by one command, what is that command you are going to use? It is called as legend. I'm sure that during your Matlab on-ramp course, they have shown you different displaying strategies and functions. So this is the legend command, and not only display, but at the same time at the top it is written that which waveform is what. So sine 1, the first thing, that is a sine 1 is given by the red. So whatever is given, it is very clearly given here. You can find out. So this is sine 1 is the red. So this red is the baseband signal. So between 0 to 2 pi, red is stretched between 0 to 2 pi. Okay, so 0 to 2 pi means 6.28. So this is the first point. What is the first point? Amplitude is 0 0, and this is the last point. So x will be 6.28. You can check. Okay, so x is 6.28 and y should be 0, like that. Then what is the second harmonic? What is meant by second harmonic? Second harmonic means it is nothing but 2 of baseband signal. So between 0 to 2 pi, if there was one red waveform, then second waveform is given by cyan. Okay, so cyan is nothing but which color you can find out. So this one. So this little sky blue kind of thing. Okay, this is a cyan thing. And how many cycles? So this is first, second, it is going on, and then it is coming, and like this. So 2 cycles of cyan, then 3 cycles of green. So this is the green waveform, very light green. Okay, like this, 1 2 and 3, 3 waveforms of light green. And then 4 is nothing but black. So you can find here very clearly, that is black 1 peak, black 2 peak, black 3 peak, and black 4 peak. Okay, so likewise you can find out, if you want, you can check this waveform bigger in this. So these are the waveforms, all the 4 waveforms you can see here. So just double click on the figure, it will show you the figure. And here harmonic, so there's a code and there's a figure. So this is the how you can see the thing in a bigger way. So red is the baseband signal, then cyan is the 2 into baseband signal called as second harmonic. There is nothing called as first harmonic. First harmonic is called as baseband signal. So red is the baseband, cyan is the second harmonic, green is the third harmonic, and black is the fourth harmonic. So likewise you can find out. Now I can play with the second harmonic. So where all the play can happen, now I am telling you. Okay, so here the time you have said 0 to 2 pi, 0 to 2 pi, let it be like that. Sine t minus 1 if you can do. Let's see what happens. Okay, so plot sine t minus 1. Let's see if there happens any change or not. So time axis I'm changing. Instead of t, what I'm doing is sine t, I'm just shifting it to right side by 1 unit. Just see what has happened. Okay, so the red has shifted by 1 unit. Okay, red has shifted by 1 unit. Okay, so wherever you are finding this thing red, so now you have delayed the red waveform by 1 unit. Likewise. Okay, and instead of 1, if you are saying that by pi, okay, so shift the waveform by pi, then what happens? So pi means or pi by 2 you can do, so that is better. So sine 1 is equal to sine t minus pi by 2. So many people have joined initially, but they have left in between. Now I am having only how much? Only 23 people. It's good. Bigger things, good things is happening toward the end generally. Now see that this is a perfect cosine wave. Okay, so red is a perfect cosine wave. So you are delaying the sine wave by pi by 2, and what you are getting is a cosine wave. Now you can advance this sign also by pi by 2. Now let's see what happens. So you are advancing the sign by pi by 2. Then let's see what happens. So we are displaying it from this is the display grid. So for all waveform it is between 0 to 2 pi and minus 1. So see that this is also a cosine wave, but now the cosine wave has become the starting point is positive. Now for pi minus 2 starting point was negative. So this is how mathematics is to be understood by using Matlab. Okay, so mathematics is to be understood by Matlab in this way. That is here, if you are doing t plus pi by 2, this waveform is advanced. Advanced means all the waveforms are getting to peak into some other time. But this red, that is the baseband signal, is coming to the peak at t is equal to 0. Likewise. So this kind of changes you can make, or you can make sine 2 is equal to 2 into this thing, 2 into uh, the other thing. So axis you can you no need to show axis because axis is actually creating some problem. So instead of cyan, I am showing it blue. Okay, so these are the changes. So what made changes are made? So sine 2 is equal to 2 of sine t. Sine 3 maybe make it smaller, so 0.33. Plate like this. So 0.33 into this, and sine 4 is sine 4. So what changes I have made? I have made sine 1 is equal to sine t, no problem. Sine 2 is equal to 2 sine 2t. So I have increased the amplitude of this cyan thing. Now the cyan I have made as red, sorry, blue. Okay. So in this case, legend is not coming very proper. So you can see it here. So the legend thing should come here. It is not coming because of this slow in the internet. So now you just run it and you can check where the changes are coming. The changes are made is in sine 2 and sine 3. So sine 3 amplitude I have reduced by 1/3. Sine 2 amplitude I have made it double. Just check what has happened. Very interesting kind of thing. So this legend is not coming here. Okay. So there is a problem. Legend also should come. So what I've done is sine 1. So sine 1 is by red color. So it is between 0 to 2 pi, one graph. Then blue amplitude I have increased. So now blue is amplitude. There are 2 sinusoidal waveforms like this. Then green is 3 waveforms. You can find here green is 3, and black is 4. Okay, so all the 4 waveforms are with 4 different amplitudes. But no, I think red and black, they're having same amplitude. Blue and green amplitude you have changed. So this is so different kind of waveform. So you can say that, sir, I'm going to change this to cosine waveform. So this is minus pi by 2. Likewise, so t minus pi by 2, pi by 2, like this. And first remove this and save, and then run. So whatever I have given you, everywhere in every graph you have to make some change, and you have to take the output and you have to show. So now see that everything is same with the previous, but this baseband signal has shifted its coordinate. It has become like this. So this is the second job assigned to you, that is all the waveforms you have to show with some kind of shifted thing. Now third one, baseband cosine wave is and is second, third, fourth harmonic. So they are now showing all the cosine waves. Sine and cosine are just game of plus 9 pi by 2 minus pi by 2. It is not a problem. Fourth question, code, it is called as basic impulse, delayed impulse, and advanced impulse. So this is t is equal to 0 they are doing. Okay, now t minus 2 is equal to 0. So if you are doing t minus 2 is equal to 0, that term it is actually advanced. So t minus 2 is equal to, sorry, this is delayed. T minus 2 is equal to 0 means it is delayed. So let us do this. The other thing. So I'll just remove it. The figure I will remove. And so this waveform I'll keep. So I'll take a new script. I'll take a new script and I'll copy this numerical. So this is fourth code. So codes are very self-explanatory. It is given. Fourth code I'm giving, and like this. And what you can save is, save as you can say impulse, impulse, my name, like this. So it is all the game of signals and systems, whatever you have done. So signals and systems, all these things you have done. Only thing is you are now implementing it here by using Matlab. Okay, so what I am doing is first I am plotting impulse t is equal to 0. You can check the red one is impulse t is equal to 0 like this. Second one is t minus 2 is equal to 0, and this is given by blue. So this is another way you can do the time delay or time shifting. So instead of t, you are substituting t minus 2, or you can show t is equal to 2. T is equal to 2. Both the things are okay. Either you are mentioning t minus 2 is equal to 0. It means t is equal to 2. Okay, or t plus 4 is equal to 0 means you are having a 4-unit advanced impulse signal. Okay, likewise, what all changes you can make here? So the same thing I'm going to show you as instead of t minus 2, what I can do you is t minus 2 is equal to 0 it was. So now what I'll make is t is equal to t is equal to 0 is equal to 2. So I'll remove this. Okay, and I have made these changes. Impulse t is equal to 2, and t delayed impulse. So delayed impulse you magnify by this, not 2, make it 3 units. So this is another thing I have done. What I have done is I have amplified the delayed unit 2 impulse, whatever is the delayed impulse by 2 units, that I have magnified by 3 units of time. Sorry, 3 times. So amplitude I have increased by 3 times. So as you have increased the amplitude here, y-axis, so this is axis for all the graphs. So now you have used the legend command. Legend command means delayed impulse, advanced impulse. Advanced impulse I am not changing. Advanced impulse I am keeping as -4 only. Okay. If you want, you can make it half. So advanced impulse, you can make it 0.5. So 0.5 multiplied. Okay. So now maximum amplitude is 3. So that's why you make it 3. So 3.05 you make it. So axis between -5 to +5, because here it is displaying at -4. So -5 to +5 is okay, and here it is from -0.05 up to 3.05. Why 3.05? Because here for the second I am getting the delayed impulse amplitude as 3. So whatever code is given to you, make some changes. So now I am shifting the waveform, the delayed impulse. 2 ways you can show. One is t equal to 0, or t minus 2 equal to 0. So both the things is equal. Now see that. Okay, so this is the delayed impulse by 2 units, and this is going to +2. So it has gone to +2, is like this. So there is no problem. Okay. And second one is this amplitude I have made it half. So this is the advanced impulse amplitude I have made it 0.5. So this is 0.5 like this, and this was at the same place. So there is a unit impulse at t is equal to 0. So likewise. So this is the way we are supposed to change it. So title is basic and time shifted impulse and legend and other things. So this kind of thing I can get. So graph also I will remove like this. Are you with me, you guys? What all codes I am showing, impulse and other thing. Anybody please respond. At least it is visible or not, because you can see this and you can do it. So Kiran, are you okay with me? Deepak, Abrar, thank you. So go slow. Okay, I cannot teach fast. I go slow. So if students feel that I'm going very slow, they can do it on their own. You can leave this session. I don't mind, because it is not compulsory. Okay, thank you, Kiran. Okay, now basic unit step, delayed unit step, advanced unit step. So all the thing they are doing it unit step. So now previously it was t is greater than equal to 0. Now it is t minus 6 greater than equal to 0. That means t greater than equal to 6. Okay, so t greater than equal to 6 means actually it's a delayed step. And t plus 4 greater than equal to 0, that means t greater than equal to -4, that means it's an advanced step. So this will be shifting left. This is an anti-causal signal. And t -6 greater than equal to 0, this is too much of a causal signal. So all the things already have shown you in the first code itself, where we have displayed. So very properly it is done. You can see that this is a advanced thing, and this is a unit step, and this is a delayed unit step. So all these things are given, but what you can do is you have to create changes in amplitude as well as in time. So with both the changes, you have to show what is the output and all. Now, damped oscillatory waveform. This is very important. And this is a graph which we will be again doing in experiment number 2. So sorry, experiment number, I think whatever comes, this is called as the second order system response. So RLC circuit time response, whatever RLC circuit response you have seen in resonance, actually that is RLC circuit frequency response. So you are giving different frequencies and you are getting what is the output at particular frequency. But now what we are going to say is what is called as, if you are giving a unit step input to RLC circuit and you are taking the output across capacitor, then what happens? So this is the modeling related output, and exactly this kind of step response we are going to find in case of RLC circuit modeling. So I think time response and transient response, all those things are there in your network syllabus as well. So this is a very important kind of waveform, and what all things that rise time, delay times, all the times, peak overshoot, rise time, delay time, all those things we can find out from the second order system response, provided we are getting an internet connectivity. So let us take a new script, copy it, and is like this. So if you click there, it will come. So now I'll save it as, so I have taken this code which is there at page number, so this is at page number 9. Okay, so this code I have copied and I have saved it, and I'll save it as save as second order. So order 2 time response. Likewise, I have saved. Okay, now let us see the code and let us understand the code, what it is. So this is first clear all, CLC close all, it is there. 0 up to 10 with a step of 0.01. Okay, so between 0 to 10, I am actually creating 10 by 0.01. So 10 by 100, so 1000 points I am creating. So A is the sinusoidal frequency, B is the decreasing exponential coefficient, C. So actually we are plotting e raised to 80 sine bt or e raised to minus 80 sine bt. Okay, or e raised to minus 80 cos ct. So all those things, e raised to 80 bt, positive, negative, all those combinations I am seeing, because this is called as a damped oscillation, DAMPED. And whenever I am finding sine 80, okay, perfect sine 80 sinusoidal, but whenever the sinusoidal waveform is like the waveform you have seen in case of second order system unit step response, that is oscillating like this and slowly it is coming to a steady state. You had found out settling time, you had found out what is meant by peak overshoot, all those things you had found out there. And there's a very big discussion, a lot of discussion will happen on this in control system also. Okay, so this is the waveform. So figure 1. So this is another way of displaying. Okay, so what is that? This is figure 1. Figure 1 means there will be 2-3 figures. So figure 1, figure 2, figure 3. So there will be 3 figures which will be coming one after another. So if you're doing it in Matlab, which is installed in your laptop or PC, cut, 3 windows will come. So previous case in Subplot, we were displaying all this 3 waveforms in Subplot. So maybe 3 or 311. 311 means there are 3 row 1 column. So 311, 312, 313. You could display all these 3. But now figure 1, figure 2, figure 3, different windows will open for figure. What is the first figure? Y1 is equal to e raised to bt sine 80. So you have to define what is the b value. So b value is -1. That means e raised to -1 into t sine 80. So sine 80 means sine 5t. Omega is equal to 5. So if you're displaying between 0 to 10 axis, so let us display all 0 to 2 pi. So let us always display between 0 to 2 pi. It will be easier for us to understand. Always display between 0 to 2 pi. Here it's not necessary. So here also axis is there. So everywhere they are showing axis. Why not in the second case? Title. Let us first plot it and let us see what it is. So first graph is e raised to bt sine 80. So b is minus. So this is going to be a decreasing exponential. So whenever sinusoidal waveform is sine AT is plotted, it is like this. Sinusoid is within plus Vm and minus Vm. If it is e raised to minus t sine AT, means e raised to minus t, it is a decreasing exponential. So that is getting superimposed on sinusoidal. That means the amplitude of sinusoidal will keep on decreasing. Okay, and whatever waveform you have generated for second order system RLC, that is actually produced by this e raised to minus t sine AT, because b value is minus 1. Next is C. C is equal to 1. Okay, C is equal to 1 means this is exponentially increasing sinusoid, but C is equal to 1. That means e raised to t. Okay, so it will be an increasing, e raised to t is an increasing kind of a waveform. And you remember that whenever the waveform is e raised to minus t sine AT, this is a decreasing kind of sinusoid, but this is stable because amplitude is decreasing. But e raised to plus t sine t, e raised to plus t sine t means exponentially increasing. So as time goes by, the sinusoidal waveform amplitude is increasing. So this e raised to AT sine AT. So there is a expanding sinusoid. This is an unstable system output. So if I say that e raised to AT or e raised to t sine t, this response is obtained from a system. Comment on the system. So you have to say that this is a increasing sinusoid response from the system, and system is an unstable system because area under the curve is going to be infinite. All this concept we will see. Last one, e raised to dt sine AT. So what is the value of d? D is nothing but 0. That means e raised to 0t, that means 1. So this thing, waveform 3, is going to be called as a sustained oscillation. That means this is nothing but sine t. Let us see the waveform and we will understand what is it. Okay, so what is the problem here? If you are having some problem in the code, it is coming in case of red. So check for incorrect argument data type or missing in call or action clear.
Sir,
Clear
it is a capital,
defining,
sir.
oh, C, capital C. So whenever you are doing this coding, remember if this kind of things are coming, you have to correct it. So clear all, clear is small c. If there is any kind of mistake in the thing, it will prompt you. Check the prompting and execute. So figure 1, figure 2, figure 3. This is for a change. You can check 3 figures. They have opened figure 1, figure 2, and figure 3. Okay, so figure 1, what we have found is it's a uh, oscillation, but here it is not perfectly sinusoid. Okay, it is there is a frequency 0 to 2 pi. So 0 to 2 pi, you are finding how much is the frequency? Frequency is 5. So you can find here 1, 2, 3, 4, and 5. So there are 5 oscillations. Is it understandable? Okay, make b is equal to 0. Let's see. Make b is equal to 0. So actually what we are plotting is e raised to bt sine sine AT. Okay, so if you are making b is equal to 0, let's see what is figure 1. So here exponential bt, be with me, okay. So here you are finding that if b is equal to 0, that means you are not creating a damping. That means they are between 0 to 2 pi, that is one cycle, there are 5, because we have defined the frequency of the waveform to be 5. Here you just check, here it is said that a is equal to 5 sine AT. Okay, so you cannot see the amplitude because amplitude is going to be 1, and here we have made a mistake, so this should be 1.2 to plus 1.2. Likewise, if you're doing,
Sir,
then it is easily visible. So please stay on with me because we are entering the main part of this waveform generation. Okay, now see, here what we have made is b is equal to 0. This is actually the waveform same as d, last one. This is called a sustained oscillation. Sustained sinusoidal oscillation means what? Whatever exponential. So what we have done is exponential and sinusoidal we have mixed together, superimposed, multiplied, and then we are displaying. Then different coefficients of exponential. So this is a exponentially decreasing sinusoid. So minus bt. Okay, so if b is equal to 0 I am keeping, then actually this is the waveform. Okay, this is the waveform of sine AT, sine 5t. This is the waveform. Now what I'm making is b as minus 1. Okay, so now the change will come, you will understand. So this is the waveform. which when multiplied with a decreasing sinusoid, so previously I have taken as e raised to bt, but b was 0. That's why e raised to 0, e raised to 0 means 1. So it was not a decreasing sinusoid, it was only a sinusoid. But now as I have made b is equal to -1, check. So is this fundamental understood? So whatever is the sinusoid, as time is going by, it is getting affected by the e raised to minus t. So as time goes by, e raised to minus t amplitude keeps on reducing. Hence, this sinusoid amplitude also keeps on reducing. This is the fun of signals and systems that I doubt you found out during your third sem. So signals and systems is all about playing with the signal. So you did not get enough time or whatever, but you could not understand this. So this is called as a damping. And what is the damping factor? Damping factor is generated by this B. Now you want a slow change. You want a slow change. Okay, so you want a slow change means what? You just make it 0.1. So B, now your B is e raised to minus t. Now what you make is B as minus 0.1 t. Let's see what we get. So it is decreasing sinusoidal, it is exponentially decreasing sinusoidal, but decrement you are reducing. That means it is not very fast falling. Okay, it is not very fast falling, it is slow falling sinusoid. Just check. Is it understandable? Is this fact understandable? Anybody? Anybody? Can you just confirm? Is this decrement factor understandable or not? No? Vaishnavi, thank you. Abrar, A division students, Dia. Okay, so you can play with this. So e raised to minus 5t. Just make it -5. B is equal to -5. So this is still sinusoid and it is reducing, but reducing slowly because now my decrement e raised to minus t is having a lesser coefficient. Okay, so B is equal to minus 0.01 t karo. So almost it will look like a sin t only. Further you reduce. Okay, further you reduce, and what you will find is e raised to minus 0.0.01 t, the red graph, because here it is red, you can understand ty1. Okay, देखो थोड़ा सा decrement है, थोड़ा सा decrement, because here the amplitude is 1 and here the amplitude is around how much? It will show how much is this? So 0.92. Okay, because now the B is 0.0.01. So initially what we had shown is it was B was equal to -1 like this, -1, and if it is -1 then still 5 cycle will be there between 0 to 2 pi. Okay, but there will be fast change. Okay, is 5 cycles visible to you? So 5 cycles. So this is the first cycle, this is the second cycle, this is the third cycle. So you can see here this is around 2.5. Okay, so this is 3.19. 3.19 means almost 3.14. That means almost it is pi. So you are displaying from here to here 2 pi. So pi mein it is showing 2.5 cycles, and right side of the pi it is showing 2.5 cycles. Likewise. So here also there are 5 cycles, but the right side cycles are getting damped. Okay. Now if you just making it e raised to -2, यहाँ पे 3 cycle at least दिख रहा है, 3-4 cycle at least दिख रहा है. Just make it the decrement very fast, steep decrement. So there's a stable waveform. Why stable waveform? Because the sinusoid is coming back to the value of the input. So this is called a step response. Okay, just say this is I have made B as -2. As I made B as -2, सिर्फ 1-2 ही oscillation दिख रहा है. Okay, so this is the effect of decreasing sinusoidal. Now make it 5, e raised to -5, e raised to -5. Just check what happens. So as you are reducing the oscillation, system is getting more stable. So e raised to -1 is stable, e raised to -2 is more stable, e raised to -5 is further stable, very highly stable. You can find out. Okay, देखो थोड़ा सा overshoot, and then it is coming to the zero value like this. So this is how the decreasing exponential value affects you. So initial value was -1. I will keep you to that initial value is -1, and figure is something where the graphs are actually shown separately. Okay, so it is like this. Okay. So this is my question to you all. Have you understood the effect of falling coefficient? So e raised to minus at. Okay, if you are changing the value of a, if you are taking the value of a too big, that means the fall will be very fast. Sinusoidal waveform will not show any oscillation. But if a value is less, e raised to minus at, a value is less, in that case some oscillation will die down slow. Okay, likewise. Same thing happens in case of figure 2. So now we are not interested about figure 1, we are interested about figure 2. Okay, so figure 2 again we have to arrange the scale because it is going to be increasing very fast, because C we are taking as 1. Let us take C as 0.0 or 0.1. Okay, then you'll be able to understand it properly. So let us take C is equal to 0.1 and let us plot up to 0 to pi. 0 to 2 pi we have plotted. Okay, 0 to let's say 0 to 2 pi, 2 into pi. So I'm changing the time axis. I'll be plotting only up to 0 to 2 pi with a sampling time of 0.01. Okay, likewise. And grid on, what is the grid? Grid you should understand that whatever you are seeing in the back, so x-axis, y-axis lines, the grid on is another function to find out the instant changes in the waveform. We do this grid on and you can put a semicolon after that. Okay, so exponential C into t. So e raised to positive exponential into t. So here I have take C value as 0.1, or I'll take it little higher, 0.3 I will take it. Okay, so this is the second waveform we are checking. First waveform is done. So e raised to 0.3t sine at. Now what is at? A is nothing but equal to 5. So between 0 to 2 pi, you will be finding there are 5 cycles and with increasing exponential amplitude, and the graph is given by blue color. So exponentially increasing sinusoidal oscillation. It is like this. So the graphs will come. Figure 1 we don't want to see. We are only concentrating in figure 3. Dekho. So what has happened is it has exceeded. So if we don't show the axis, if we just don't show the axis, I think it will be better. So as we are mentioning the axis, it is displaying only within that axis, but the amplitude is actually crossing minus 1.2 and plus 1.2. That's why it is going beyond the scale. So we are not interested about graph. This is what it is. Very fine waveform. So you are finding there are 5 cycles. Why 5 cycles? Because you have defined A as 5. You can check here. You have defined A as 5. Okay, you have defined A as 5, and you are saying here that e raised to ct into sine at. And what is the value of C you have taken? C value you have taken as 0.3. Okay, that means e raised to 0.3 t into sine t. That means as t is increasing, e raised to 0.3 t is increasing. So there are 5 cycles. Exactly the same thing happens in case of e raised to minus 0.3 t, but initially it is high value and towards right it is low value. Now this is called as a damped, DAMPED, but this is called as a oscillation which is increasing sinusoidal. So this is the system which is producing this kind of output is actually a unstable system, because here as time goes by the waveform is increasing. So this is the output of a unstable system. And if you want to decrease the oscillation, suppose you want to see only 3, so make A is equal to 3. So these are the changes you have to make and you have to show, you have to submit. So all the graphs whatever is given, okay, all the graphs whatever is given in the 19 pages, exactly the same document you have to submit, but with all waveforms changed. Not a single waveform in my document and your document should be same. So either you do amplitude scaling or frequency scaling. Now see here, I have made A is equal to 3. Okay, that's why between 0 to 2 pi you are finding there are 3 graphs like this. So there are 3 cycles like this. Okay, so this is for the increasing oscillation. And last one is what we are doing is e raised to same thing, e raised to dt, but d value we are keeping as 0, exponential dt, or you can just remove it. You can just play sine t. Okay, like this, either e raised to dt. So d value is 0. D value is 0 means you are going to find like this. So e raised to dt 0t, and here axis I am showing, so axis between 0 to 10. That's why it is showing up to 0 to 10. But we can control it. We will display only up to 0 to 2 pi. So save it and run it. So all the three things will come, figure 1, figure 2, figure 3. So first thing in figure 1 also you will be finding that there will be coming only 3 oscillations. So this is first oscillation, this is second oscillation, and this is the third oscillation. So there are 3 cycles. In figure 2 you will be finding this is increasing oscillation. Okay. So in figure 1 it was decreasing oscillation. If you want to see all the 3 cycles, then B value you have to just change a little bit, 0.5 you can make. So very nice kind of waveform we want to get like this, or 0.7 you can do, or it is 0.6. So very nice kind of waveform. I'm just giving you a hint how to generate. So increasing exponential, decreasing exponential, and why am I giving so much time on it? Because in the second order RLC system step response, we're going to see this. So just check A is equal to 3. So there are 3 cycles. This is decreasing exponential, and second one is this is increasing exponential. This is unstable. Decreasing exponential is stable because it is coming to the 0 value. And finally, we are going to find this is called sustained oscillation. Sustained oscillation means there is a sinusoidal waveform. So e raised to minus AT sine BT is called as a decreasing exponential. E raised to plus AT sine BT increasing exponential, and e raised to 0 into AT sine BT, that is called as a sustained oscillation. So generally we are seeing this sustained oscillation of a sinusoidal waveform. Okay, so this is about all the waveforms and everything. Just give me 1 minute. Give me 1 minute. So we are still having 10 minutes in our hand. I'll leave you at 5 only. So what all waveforms are there? Let us find out. And interesting cases are there. We will see. So these are all waveforms explained to you what is meant by decreasing exponential, increasing exponential, and all. So generation of so this is code number 7 is very important. We'll do that. And after code number 7, what all things are there? Just let me check. So this is a algorithm that I'll tell you how to generate a half waveform. So code 7, if I tell you, you'll be able to generate. Okay, so code 7, code 8 in the same line. Effect of sampling time. This I have already told you. So just keep on changing the value of sampling time, and whatever you'll be finding is the effect of aliasing. Okay, so that you will find. I gave time. Okay, just see if you are taking sampling time very less. Oh, sorry, sampling time very high. So big sampling time is bad. Peak sampling time means smaller sampling frequency. That is bad. Okay, so this is a case 4. Like this is bad. So what you have to do is you take so a little bit smaller. Still it is bad. Okay. Here you have said so just read this document carefully from the beginning to the end. Here also you have taken the sampling time. So generate a sinusoidal waveform and keep on changing the sampling time from some value to the smaller value and all. So here you are keeping the sampling time as 0.01. It looks like a sinusoidal waveform, but if you zoom this part, top any part, it will be looking like this. Okay, so this is the sampling frequency at 100 Hertz for 3 Hertz signal representation. And now finally, this is 200 Hertz. So you want to actually display, reconstruct a 3 Hertz signal, but you are taking sampling frequency as 200 Hertz. Okay, then also you are finding some kind of, so this error is due to the quantization effect. Oh, this is the sampling effect, aliasing. And finally, you can check. So this is, we want to display the same thing, 3 Hertz signal, and here you have taken sampling frequency as 1000 Hertz. Okay, sorry, yes, 0.001. So 0.001 means 1000 Hertz. Likewise. And lastly, just check. Yeah, very smooth waveform, very smooth waveform. So 0.0001. So you want to display 3 Hertz, but you are taking sampling frequency as 10,000 hertz. Okay, so what does Nyquist rate say? Nyquist rate say if you want to represent 3 hertz baseband signal, you can keep sampling frequency as 6 hertz. So that is the boundary condition. That is not the best condition. Best condition is what should be the ideal sampling frequency? Answer is infinity. Okay, if you are taking infinity hertz, then best reconstruction can happen. But infinity you cannot take because there is a bandwidth constraint on the system. So we want to display actually a 3 hertz signal. We want to regenerate this 3 hertz digitally. What is the actual sampling frequency I'm taking? Sampling frequency I'm taking as 10 kilohertz. Okay, and then you are finding very perfect reconstruction of sinusoidal signal. So it is saying that perfect output sine wave and even perfectly reconstructed top part is shown in figure 9a and 9b. Okay, so this is the sinusoidal waveform and top part is 9b. No aliasing error is viewed on 9b, so it is concluded that higher sampling frequency gives better signal reconstruction and minimizes the aliasing error. Anyways, so we are going to finish the session with this graph. Okay, so code number 7 and code number 8. What does code number 7 says is generation of full wave and half wave rectified waveform. So code number 7 I will see. You don't need to just do the coding, you just see what am I actually doing. So it is nothing but mix and match of some things. So I will remove this and I will remove this figures also. Okay, and I will take this code. So command window I will remove and I'll first save it. I'll save it Saurav HWR. HWR stands for half wave rectifier. So only HWR if you give, it might get stuck. So that's why Saurav HWR. So generation of input 1.8 volt peak 4 hertz sine wave. So the question is, I will give you any voltage peak. So generate a 3 volt and 10 hertz sine wave. That can be the question. Okay, so here I am asking you to generate a 1.8 volt peak and 4 hertz sine wave, and lean space command you can use, and there are other things. So clear all, here also clear is capital C, so that you have to make small c. Be careful. And lean space t is equal to lean space minus pi to pi 1200. What is meant by that? Okay, so means minus pi to pi is the 2 pi gap, or you can say between 0 to 2 pi also. Okay, so minus pi to pi, what happens? 0 to 2 pi also the same thing happens. And between minus pi to pi, there are 1200 samples. So lean space command, it says first time range is specified and then required number of sample. So previous case we showed you. So between minus 5 to plus 5, there were sampling instant I have mentioned. T is equal to 0.01. Means every time instant second is going to divide it by 100. In the previous cases, minus 5 to 5 with sampling time instant as 0.01. In this case, not that. In this case, minus pi to pi is the time instant. It is going to be divided by 1200 samples. So whatever is the sampling time, you can calculate from that. So sampling instant, there are 1200 sample in between minus pi to pi. So frequency hertz is equal to 1. Input sine wave is equal to 1. So whatever waveform we are generating, it is 1 hertz 2 pi frequency. Okay, HW, so frequency hertz time. So this is actually frequency in hertz into time. So this is 2 pi ft and amplitude is 1.8. So first job is to produce a sinusoidal waveform of 1.8 volt and then some frequency. Okay, so I'm just commenting it. And then save and run. So there are 4 plots. Subplot 411. Subplot 411 means this is a 4 row 1 column. So there is a sinusoidal waveform which I have generated first. So we don't have a signal generator. So first we have to produce a sinusoidal waveform and then we will go. Now the problem is here it is from minus pi to plus pi. So if you want from 0 to pi, then you have to go like this. Generally we are habituated in seeing sinusoidal waveform increasing. So it's from 0 to positive side. So in lean space, if you can just, I'll show you the change. In lean space, if you are saying that plot from 0 to pi. So in lean space also you should be able to understand what is happening. So if you're doing it from 0 to pi, then what will happen, you check. Okay, so it is from 0 to pi. Why is it showing the negative side? Because my axis I am plotting from minus pi to pi. So if you comment this axis as well and leave space from 0 to pi, then you are going to find perfectly starting from 0 and going up to pi. It will be displayed here like this. Now it is starting from 0 and going up to how much? Going up to pi. So this is 3.14 you will find. Okay, this is 3.14 you can see here, and 0 to pi. So either you can do it from 0 to pi or you can do it from minus pi to pi, doesn't matter. So as the axis and everything is set for minus pi to pi, so I will go with that. So this is the first graph I have generated, the sinusoidal waveform for minus pi to pi. Then what? Then actually this part, what it is doing. So this is uncomment. Then the second part, y is equal to absolute input sine wave. So absolute you are doing means whatever is the negative part, that will become positive. So if you are doing absolute, it is actually full wave rectification. Just check. So this is the subplot 412. Subplot 412 is absolute value of input sine wave. So we have seen the absolute comment. Absolute comment does what? It takes the negative axis. So there is a negative axis. Negative axis is going towards positive. See, this is a negative axis going towards positive. So there is no negative amplitude. All the negative will become positive. Now what we have asked you is generate a half wave rectified waveform. So what is the question? So remove the figure. What is the question? Generation of input waveform of 1.8 volt peak done. Half wave rectified. So now you are having two waveforms like this. Two waveforms like this. So it is all about signal manipulation. Don't think of circuit. Circuit is different. Now I have given you two waveforms. I have asked you to generate half wave rectified waveform. How can you do that? Answer is add these two. Add these two. If you are adding this to this negative half cycle and positive half cycle at this negative points, okay, they are cancelling each other, and all the positive half cycle is becoming double. Okay, so how can you generate a half wave looking half wave rectified looking output from these two? You have to add these two. If you are adding these two, then what happens is all the negative peak in the sinusoidal waveform is removed, because negative is getting added with positive. So they will be removed, they will be flat, zero, and the positive thing will show the highest double amplitude. So this positive, this is 1.8, here also it is 1.8, so this will become 3.6. So just do that. That is the third part. What I'm doing is I'm adding actually these two waveforms. So do this uncomment. Subplot. So what you are doing is z is equal to 0.5. So what is 0.5? Now this, if you are adding these two, this and this addition, so this peak will become 3.6. But if I'm doing 0.5, then it will become 1.8. So that is the third step. So if you are adding these two, the negative half cycles are cancelled and positive half cycle will be produced as double, but with 0.5 again it will become half. So just see what is the third waveform. Understandable? So just check wherever third waveform is there, that third waveform is actually addition of these two. But this peak is 1.8, this peak is 1.8, but this peak is not 3.6. This peak is still further 1.8. Why is it 1.8? Because we are adding these two and multiplying it by 0.5. Whereas you can check here, this plus and this minus. So how you will generate this plus? You have made the absolute out of it. So first the red waveform, then put absolute command on the red waveform, you are getting the pink waveform. Pink waveform is a full wave rectified waveform, but I have asked you to produce a half wave rectified waveform with a positive half cycle. So only we have rectified the half wave rectified waveform with the positive half cycle. Now somebody says something else, negative half cycle we want. So what we are doing is 0.5, but we are generating something. So let's see what it is. So make it uncomment. So this is the last thing. 2 minutes more. I'll leave you and run it. What you are doing is you are now minus y plus input. Whatever you had got in the second waveform, you are adding negative of it with the top one. So fourth waveform, you will be getting a negative. Okay. So the same thing as you got here. So previous case you are generating absolute, but in the next case what you are getting is these two waveforms you are getting. Okay, then what you are doing is minus y. What is the y waveform? Y waveform is nothing but the rectified waveform. So actually I have made a mistake. I have to do like this. Okay, so there are four waveforms. In the second case you are generating y. So this is y. In the fourth case, what you are doing is you are making it first minus y. That means all the negative half cycles are there. So negative half cycle, whenever they're getting with negative, that means this pink waveform is getting inverted. Okay, that is what you are doing. Minus y. So y is nothing but the absolute. Minus y means you are converting this thing into half wave rectified, sorry, full wave rectified waveform, but with negative cycles. So all the half cycles are coming in a negative direction. Then add it with the top waveform. Top waveform is nothing but input sine wave. So if you're doing that, then what happens? All the negative half cycles are preserved, and all the positive half cycle and negative half cycle, they are getting cancelled. And then again the same thing will happen. Negative half cycle will be having amplitude as 1.8 into 2. Then again you have to do with 0.5. So this is a pure logic that we are doing. Question is generate a sinusoidal waveform like this, then generate half wave rectified waveform and full wave rectified waveform. So first step is to generate a full wave rectified positive, and then you can generate the full wave rectified negative also. So if you are adding full wave rectified positive with sinusoidal and multiplying it by 0.5, you are going to get half wave rectified positive. And if you are generating full wave rectified and inverting it, okay, that means you are getting full wave negatively rectified. That if you are adding to actual sinusoidal waveform and multiplying it by 0.5, then you are getting the negative rectification. Okay, and if you want, you can generate a 0.7 volt, whatever problem is there, that 0.7 volt, that also you can generate in case of, so there is a diode rectification, that also you can generate. So in whenever you are submitting this assignment, try to show me that 0.7 volt effect in half wave rectification as well as in full wave rectification. So that's all from my side. So I've explained all the codes to you. Then also if you are having any problem in any of the codes, please let me know. Okay, so that's all from my side. If you are having any doubt, you can ask, or else we will log off. So by Tuesday, let us by Wednesday. So we'll keep chalo Wednesday, Thursday morning before 9. You submit this all the experiment outputs. Every output should be changed and read the whole thing. Whatever I have written, let the writing be the same, but your explanation, the values will be different and graphs will be different. So generate the same kind of graph, put it in the same place, but with some deviation. Same kind of graph, not same graph. Don't submit my graph to me. Whatever document I have prepared, don't submit my graph to me. Make some changes, tell about the changes that I have shifted it by time, I have shifted the amplitude, I have increased the amplitude, decreased the amplitude. Be some way different. So I think instruction is clear. I'll be expecting your submission in Google Classroom. Don't email it to me. All the control system experiment submission will be in common Google Classroom for ABCD division, because there are 3 more professors who are teaching it, so we are able to keep track. OBA assignment and all those things you can submit in our personal group, but experiment submission you have to do in common group. That's all from my side. Thank you. If you are having any doubt, you can ask. Good day. Good day, Abrar. That's all. Any doubt anybody wants to ask? Okay. Thank you. That's all then. Bye.